SMMR, also known as SUMMER, stands for Sustainable Urban Mobility in Metropolitan Regions in ASEAN. SUMMER is an ASEAN-German cooperation project with the objective to implement concepts and strategies for integrated and sustainable mobility across the 10 ASEAN member states. Since 2019, SUMMER is developing 4 knowledge products in the form of green papers and webinars, and this covers the following topics: SUMPs, Sustainable Urban Mobility Plans; MTEs, Metropolitan Transport Executives, Smart and Open, which refers to smart and open traffic management; and finally, HUBs, which refers to intermodal interchanges. Since 2019, SUMMER is also supporting 3 metropolitan regions established ready to implement pilot projects. These metropolitan regions include Phnom Penh in Cambodia, Can Tho in Vietnam, and the cross-border region between Vientiane Lao PDR and Nong Khai in Thailand. The SUMMER German Cooperation Project is implemented by GFA Consulting Group together with Clean Air Asia, the Wuppertal Institute, and Ruprecht Consult on behalf of GIZ and the ASEAN Secretariat. For more information, visit us at www.summer.asia or find us on LinkedIn and Facebook.
Firstly, welcome and thank you so much for joining us in this second episode of our Open Data webinar series. Today's session is Open Data in Action, and we are going to talk about good practices. In the previous session, the session 1, we have discussed on the basics of open data. We have defined what open data is, and we have seen from experts there on how open data can be used by cities for their benefit and what synergies exist both in passenger and freight transport. So in this session, what we are going to see is what happens to cities when such practices are put in place and what kind of synergies arise, and what opportunities are there when data is embraced by cities. And to deliver this, we have a great panel of speakers ranging from city administrations, academic institutions, and also private entities working with cities on enabling cities to activate the data utilization techniques. First presentation is a good practice from the Seoul metropolitan region in Korea. And to share this experience, we have with us Mr. Dong-Hoon Shin, the policy advisor for the Seoul Urban Solutions Agency. Dong-Hoon is responsible for strategic partnership management, project development, and project delivery in the field of sustainable urban development. Dong-Hoon is extensively involved in leading partnership efforts with international organizations for project development and collaborations to produce development knowledge focusing on integrated cross-sector approaches to analyzing and addressing urban development challenges. Dong-Hoon has prior projects in consulting, policy advisory, and project development and implementation, with a focus on cross-sectoral issues including smart cities, governance, and climate change. He has professional experience in Europe, Africa, and Asia and Pacific, and working with organizations like the World Bank, the European Commission, Asian Development Bank, and other bilateral ODA and development cooperation funds. So, Dong-Hoon, the floor is yours.
Yeah, hi. Thank you very much for the introduction, Sunny. As Sunny outlined very well, my name is Dong-Hoon Shin. I prepared a presentation that sort of delves into the some examples of how we utilize data and how we manage data for transport policy and public service delivery here in Seoul. I hope it can give you all a sense of the enormous role that data plays in providing, convenient, safe, and reliable transit services for citizens here in Seoul. I believe my presentation has a pre-recorded narrative, so I think I can just sit back at this point and let you all enjoy. So yeah, thank you once again. It's a great pleasure to be here. Good afternoon, everyone. Today it's my pleasure to present to you an overview of Seoul's data-driven transport policies. My presentation will begin with a brief introduction to myself and the agency where I work. Give you an overview of the Transport Operations and Information Service, or TOPIS, which is the central platform infrastructure that makes up the backbone of Seoul's data initiatives in the transport sector. Then I will give you a bit more in-depth explanation of the different systems and data architectures of TOPIS, so as to give you some insight as to specifically how data is originated, managed, and utilized in transport policies. I will wrap up my presentation with a brief overview of some future data-driven mobility initiatives that we are currently piloting here in Seoul. Before we dive into the details, a little about myself. My name is Hoon Shin, Project Advisor at the Seoul Urban Solutions Agency, a government institution where we work to support the sustainable urban development of partner cities through policy advisory, technical assistance, and knowledge exchange. Now, I mentioned the Transport Operations and Information Service, TOPIS, earlier as the backbone of Seoul's data-driven transport initiatives. It's the central ITS platform managing Seoul's mobility needs. The first iteration of TOPIS was first introduced in 1998, which at the time only monitored road traffic along 2 urban expressways in the city. It's since been expanded to its current 3.0 iteration, and it now manages not only the entirety of road traffic and public transit operations in the city, but also encompasses disaster management, policy planning, and open data and information provision as well. Due to the comprehensiveness of its monitoring, data analysis, and management functionalities, it's one of Seoul's most important smart city management hubs. In terms of hardware and infrastructure, the TOPIS platform consists of not only the central control platform, but a wide array of various traffic-related detectors, panels, CCTVs, controllers, and on-site information terminals throughout 1,268 kilometers of the city's road network. As such, not only is TOPIS able to monitor and manage the city's road traffic and public transit operations in real time, 24 hours a day, but we are also able to collect an enormous amount of data as well. Some examples of networked infrastructure include over 800 traffic-specific CCTVs, over 3,000 traffic signal controllers, and almost 10,000 onboard units on our fleet of public buses. In terms of the data we are able to collect, we collect over 24 million data points per day, ranging in data types from GPS data to transit card data. Simultaneously, due to the robustness of TOPIS's data collection and management functionalities, we're also able to provide an enormous amount of vital information for public transit and road users through multiple modalities such as social media, website, bus information terminals, variable message signs, and open data platforms. In terms of systems and software, the TOPIS platform is composed of a number of modular subsystems and platforms, each with distinct functions. Some of the most important ones, which you can see on this slide here, include the center platform, the bus platform, unmanned enforcement platform, freeway traffic management system, the advanced traffic management system, the traffic big data platform, and most recent additions include the Green Transport Zone Vehicle Management System and the Autonomous Vehicle Testbed Platform. Although I won't have time to go into the specifics of each system and corresponding data architectures, I'll give you an overview of some of the more important ones, starting with the center platform, or the Integrated Control Center System. This system is designed to act as a central control tower for overall control of the network of connected devices, overall monitoring of general road and traffic conditions, integrated management of emergency situations, as well as data integration with external institutions such as the Korea Meteorological Administration and the police agency. The bus management and bus information systems, as their name suggests, are responsible for monitoring, management, and information provision related to public bus operations. In simple terms, the bus management system collects, manages, and processes all operational data relating to the management of public buses, while the bus information system provides consumer-focused information such as bus stop arrival times for public transit users through bus information terminals, mobile, web, etc., etc. The advanced traffic management system deals with the monitoring and management of road traffic. Data being collected through this system are categorized into 4 different types. Travel speeds collected via detectors and GPS, weather conditions being collected by the Meteorological Administration, traffic volume and situations through CCTVs, and traffic signaling operational data. We use all of this data through the ATMS to fulfill several vital functions in road traffic management, including analyzing traffic congestion by zones and roads, the planning and operation of traffic signaling, detecting abnormalities along the roads through real-time analysis of change in speed for each individual road, and perhaps most importantly, providing road traffic information for citizens through a number of channels such as broadcast, mobile, or VMS. A subsystem related to road traffic I'd like to mention is the traffic forecasting system. By analyzing historic traffic data we've been able to accumulate over the past years, in conjunction with road traffic data being collected in real time, as I outlined earlier, we're also able to provide highly accurate traffic forecasting services for citizens with update intervals depending on forecast timescales. Another vital system of TOPIS is the big data analysis system, which collates, manages, and processes all transport-related data being collected through the TOPIS platform, as well as other major data sets and policy index information from other departments at SMG and external institutions in order to draw valuable insights and deliver tangible policymaking support for the Seoul metropolitan government. You can see some examples of the data sets and analytics we work with on the big data analysis system here. These tables are far from being a comprehensive list of all data analytics on the system, but it may give you an idea of how we categorize different sets of analytics works. For example, we have general information analysis, demand analysis, and mobility analysis specifically tailored to support public transit operations. As well as data analytics to support the management of our public share bike initiatives and policies, as well as cross-cutting analyses across multiple topics in the transportation sector to support policy making. Here you can see an example of an actual data dashboard as our Seoul metropolitan government officials see it. This specific board deals with bus operations data. And in the lower left-hand corner, you can see a map visualization with overlays of bus supply and demand data analyses, with the areas in red representing areas of high bus demand. And if you click on an area highlighted in red through this dashboard, you can see bus OD information by time of day for the area that you clicked on. And you can see this graph on the lower right-hand corner. As you might be able to imagine, a dashboard like this with built-in analytics functions makes policymaking and, for example, deciding where to invest in additional bus infrastructure, routes, and intervals much more accurate and efficient. Here we can see a similar data dashboard for subway operations, as well as an example for taxis here. Given all of this, I'd like to move on to some examples of tangible policy outcomes of big data analysis and transportation, as we saw earlier. A rather well-known example is Seoul's night bus services, where big data analysis was used to formulate bus routes in place of OD data used in traditional route rationalization methodologies. And the reason for having to use a methodology like this was because traditional OD information was non-existent during hours where traditional bus operations had already ceased. So in terms of the specific data that we used instead, we utilized billions of mobile call log data points and OD information from late night taxis in order to draw nighttime mobility patterns to identify where the population tended to be concentrated at night and where they were moving around to. Using a similar methodology, we also created the Squirrel bus services to optimize bus routes and intervals during rush hours so as to most efficiently serve as many passengers as possible in a critical time of the day where traffic congestion is at its highest levels. Most recently, we've implemented a green transport zone in the city for which a specialized system was implemented to manage automated enforcement, as well as data analysis for monitoring and evaluation of the initiative. Most recently, Seoul working to implement cooperative ITS infrastructure in the city in anticipation of the development and rollout of future mobility services and solutions. An example of this in practice is the piloting of autonomous shuttle buses in the city in the Sangam region, with pilot operations having commenced in the middle of 2019. That's the end of my presentation, and I hope insight as to how data is utilized in the transport sector in the city of Seoul. Thank you.
For our next presentation, we still stay in the region, and we have, we'll see how data is shared and how data is generated and what synergies with data sharing. And to share this experience from Chinese Taipei, we have with us Dr. Tsu-Jui Cheng. He's an assistant professor at the Livable Mobility Research Lab at the National Cheng University in Tainan. Tsu-Jui is an avid walker, fair weather cyclist, and a public transport user. His Livable Mobility Research Laboratory unpacks questions about accessibility and sustainability in transport. Tsu-Jui is the former head of sustainable mobility at the ICLEI, Local Governments for Sustainability. He holds a PhD from University College London and a Master's of Science from London School of Economics. Tsu-Jui, the floor is yours.
Hello everyone, my name is Tsu-Jui Cheng. I'm Assistant Professor in Transport Studies at National Cheng University in Tainan. I would like to say thank you to SMMR for this great opportunity for me to share some of my understanding about the implementation of smart mobility and open data in cities and regions I'm living and working in. Before delving into the use of open data and smart mobility, I would like to touch upon the political framework that actually has laid the foundation work, the groundwork for the uptake of open data in Taiwan. And back in 2012, there was this wave of the call for open government worldwide and this advancement of cloud computing back then. And that actually made the national government in Taiwan started to understand and acknowledge the use of open data to enhance the circulation of information among agencies and to improve the efficacy of policies and fulfill public needs, and to make it possible for the public to better supervise the operations of government. Data is designed and planned to be made open to the public and enterprise and free of charge in principle, released and exchanged automatically and systematically whenever it's ready. And in order to achieve those goals, there are 4 focused strategies to promote open access to government data. proactive opening prioritizing people's livelihood, quality of life, drafting open data standards, which is ongoing, promoting a shared platform, which is available right now, data.gov.tw, demonstrating advocacy and service promotion. This is a screenshot of the website data.gov.uk, which shows about almost 20 categories of datasets. As we could see, transportation and communications is one of the richest datasets among all, having about almost 2,000 datasets on the website for users, for citizens, for the public, to the enterprise, and the developers to sort of to be involved in this data and to make the most of the data to supervise the government and to make policy more efficient and more effective. Now we are narrowing down from the bigger framework of open data to the utilization of open data in the field of transport. And the first ever smart card system, Easy Card. Those who have been to Taiwan might still remember this Easy Card throughout, which is used throughout the Taipei Metro network or Taipei bus services, was actually launched in 2002, as opposed to the government decision, especially from the national government back in 2012. Easy Card was actually launched a decade earlier than the national government's decision or national government's encouragement. That's because, as we know all too well, transport and communications is a subject that is way more complicated than many other subjects. And the field of transport is always at the forefront of the adoption of technologies in order to solve the mostly the traffic problems. That's why 10 years before the national government's decision, EasyCard had already been launched and adopted by local governments. But later on, it was expanded to other modes of public transport, shared bikes, and taxis. As we all know, as the advancement and improvement, and also the behavior change of the citizens, more modes of transport have been developed and included in our urban mobility plans. And this Easy Card now is even an electronic payment and wallet, not only for the government fees, but also for recreational purposes at convenience stores, shops, and restaurants. 5 years after the launch of Easy Card in Taipei, the southern city, the then second biggest city of Taiwan, Kaohsiung, also launched its own smart card system called iPaaS. The trajectory is almost identical as Easy Cards. It expanded to other modes of transport, bikes and taxis. It's now also a wallet, particularly electronic wallet for shopping and for government fees. What made or has made iPaaS different is that iPaaS has a very interesting selection of stakeholders, which include not only government agencies from local governments and national governments, and also, interestingly, the banking system and sort of the traditional banking system from the banks, Union Bank of Taiwan, but also the mobile banking system, the Line Pay, and making iPaaS not only a travel card, a sort of a smart card system, but also a mobile payment that provides more services and more functions to users beyond just a travel card. Um, Having two systems could be quite complicated sometimes, because the iPaaS doesn't or didn't work really well in Taipei, whereas EasyCar also didn't really work very well in Kaohsiung. So in 2010, the year 2010, these two cards system, smart card system, have started to integrate in its own way. The two systems remain separate. They have their own sort of companies and corporations, whereas the systems now could talk to each other. So now virtually identical in terms of the coverage of services geographically as well. And just because with the amount of data they have gathered for the past few years, they are now at the position to better integrate the bus services and provide feedback to the bus services and networks. And so, which is a very positive feedback loop. And the better they understand how passengers use other services such as bus, bike sharing, even ferries, and the better they could provide a seamless interchange between the metro systems and other public modes of transport. And this is a great example of how to use open data and to improve the sort of interchange and also and multimodality in urban areas. And even the national government decided to integrate their railways network, railway system into the easy card system and iPass system, which was supposed to be an urban mobility payment system. Just because of the better understanding of how people move about in cities, and the Kaohsiung city even launched very recently the Mango card, which is monthly travel pass, with a greater integration of the every modes of public transport that could possibly include it in the region. In the future, the electric scooter sharing system and taxi system would be integrated into this Mango card as well. And also just because they understand the usage of the public transport system, they could set a really affordable price point and for target audience and target customers. And they now also use a reward system and to really keep the users into a regular basis. And they even reach out to the local colleges and corporations and to make sure the universities and colleges and corporations will encourage the shift from the private vehicles to the public transport system. For a grander scale, grander project, the UMAGI, supported and funded, partially funded by the national government in Taiwan, is to better integrate not only journey planning timetables, but also ticketing system and first last mile movement in order to reduce the use of private vehicles, eventually to bring together the public transport data exchange providers and public transport operators. And their goal is to go beyond MaaS, not just a service, but also a tool. The tool is public and the tool is open to users and to corporates and to operators and providers to continue improving the MaaS system. So the grander scale, grander idea is to include all systems that is possibly available in Taiwan, including railway systems, high-speed railway systems, intercity buses, metro and city buses, even parking, navigation, and bike sharing system as well. And in order to really to replace the private motor vehicle with the public transit and with shared mobility. And the project has been quite challenging just because there are way too many stakeholders in this field, um, including multimodality planning, intercity transport ticketing, parking and navigating, corporation carpooling, payment and reward systems, car sharing and booking systems, and tourism and audio, even audio recognition as well for people who actually need special systems. And if I may start from the multimodality, um, as we could see probably sort of the information in some of them are in Chinese, but for the multimodality planning, the stakeholders are mostly from local governments, local public transport providers. However, for intercity transport ticketing, that involves intercity transport operators such as Taiwan High Speed Rail, Taiwan Railway System, even the telecommunication companies and intercity coach companies. And the first two stakeholders, sort of the umbrella of stakeholders, are complicated enough because they are the involvement of local governments and local public transport operators, whereas there are also the involvement of intercity transport operators and national governments too. And now parking navigating that falls into the realm of telecommunication companies, the telecommunications technologies, and the same probably for the carpooling companies as well, and the so-called the TNC companies. And the payment rewarding system would involve the smart card payment systems or electronic wallet systems. Car sharing booking is a different sort of realm with different stakeholders, and tourism audio recognition too. So this has been proved to be very challenging to really convince different stakeholders to join this journey to make MaaS a reality in Taiwan. What has been made known to the public is that despite the all good intention of the development of MaaS, it's really still very hard to make behavior change, particularly for the passengers, users, you, which means you and me, and to really shift from private vehicles to public transport and shared mobility. And the buy-in for stakeholders can be very challenging as well, because as we just saw in the previous slide, there are so many different operators, not only in the field of transport, but also field of telecommunication management, in government agencies, in startups, in banking industry, in mobile payment industries. And Umaji is not even competing with existing online platforms and apps by operators and third-party developers who might not want to give it in because, of course, they have put in a lot of efforts developing their own semi-MaaS system, and it doesn't make sense for them to really give up their own system and now join Umaji, whereas they don't really have a significant share of, which is understandable from stakeholders. That's why buying can be really challenging. Ticketing system is key because that needs a stronger integration of the financial system and banking system as well. And last but not least, I think it's important to understand local context. The lower last mile in Taiwan means the destination. And destination may mean shops, restaurants, department stores, convenience stores, and that actually goes much beyond just serve the purpose of going from A to B, but more the services around A, services around B. So Umaji is also integrating information about tourism, about say the promotion for particular destinations, and to make that as an incentive, the kind of the vehicle for people to really start considering using MaaS as the way to move about in cities as well. And so as you can see in the picture that the Minister of the Transportation even had to answer questions from the media and from the local councillors and also the members of parliament as well as to how the better to improve the system to meet the need of the general public and to meet the need of different stakeholders and to make it a nationwide app that is available to people of different needs and also people even needs different assistance too. So thank you very much. I've been Richardson. I'm happy to further exchange my thoughts and ideas with everyone after our presentation, and please keep in touch through different channels. Thank you.
So for our next presentation, we will go to Europe. With us, we have Dr. Fotis Liotopolous to share the experience from European cities on implementing open data. His company directly works with cities to help them collect data, and that can be used to plan and manage traffic in the cities. Fotis is a computer engineer with a PhD from University of Wisconsin-Madison from the US. He's the founder and CEO of sboeing.net, an innovative ICT SME in Greece, developing transport applications and systems. And he has managed over 100 ICT research projects, including the Horizon 2020, Civitas, Suits, and TIN-Go projects. He's also an academic teacher and a researcher with over 50 published research papers. Fotis will be doing a live presentation. So without any delay, Fotis, the screen is yours.
Thank you, Sunny, and welcome everybody. Thanks for the invitation. So I'm founder and CEO of SBoeing. SBoeing is an SME in Greece. We're developing applications and systems for navigation and routing. We participate in the Suits project. This is a Civitas European H2020 project. And from our experience and our work in the Suits project, today I'm going to present to you some of the outcomes. So my presentation will be about open data and specifically how to collect, be selective and visualize open data using some tools that we have developed. So in the Suits project, our vision is to support local authorities for small and medium cities in their SUMP implementation, sustainable urban mobility plans. And in particular, our goal in SBoeing is to assist with data. We're data coordinators in the project. So our vision is to do that in 3 steps. First, in assisting with the data collection, then to assist in the selection of data out of all the collected data sets, and finally to provide visualization tools that will assist the local authorities in their decision making and policy making. In the Suits project, we developed a set of tools for each one of these 3 steps, and you can see the slides. I don't have the time to go into detail, but we can discuss it afterwards, or if you can send me an email for any particular specific details. In my presentation, I'm going to present 2 types of tools that we have developed: tools for historical mobility data, basically GPX files or other formats, conversion utilities, and online databases that you can get such historical mobility data from. And the second part, tools for real-time mobility data, for data that we get from crowdsourcing. Crowdsourcing is our advocated preferred methodology for sustainable data collection by the cities. And also, I'm going to show you our open data repository that we have developed for urban mobility data. We have also developed in the Suits project a capacity building toolbox, which is, as I have the URL here, the address. You can visit it and you can see all the outcomes, the tools, and everything that the city needs for their sustainable urban mobility plan implementations. We have developed a set of tools for processing GPX files. GPX is a favored format for traffic mobility. Also, in view of GDPR compliance requirements, we provided in this toolbox a number of other tools for anonymization or pseudonymization of GPX files, which makes the collected data appropriate and available and GDPR compliant to be uploaded in open data repositories, be available as open data. We also developed a tool for the geoselection of GPX, a vast number of GPX traces available. And you can see here, don't have time to go, but you can see here that we have several thousand, hundreds, thousands, or millions of traces from all over the world, basically coming from OpenStreetMap traces and other traces of ours. You can use this tool to select any traces in any area that you want, download the traces, or even preview each individual one and be selected. So this is how we provided some tools, as I said, for dealing with historical data, for GPX traffic traces, and so on. Now I'm going to show you some tools and platform we have developed for real-time data collection in urban environments, and particularly our navigator, which is used for crowdsourcing. It's called UltiNavi, and a platform, mypolislive.net, which is for collecting and visualizing the traffic conditions in real time and historical data as well in cities. In parallel, I'm going to demonstrate some results from Kalamaria and Thessaloniki pilots, two Greek cities we did in two of our projects. So our preferred and promoted and advocated data collection model for local authorities, small and medium cities, is this type of crowdsourcing. On the left side here, we crowdsource data from different sources, from freight, from citizen vehicles, from city vehicles, citizen mobility data, and so on. We process them in some cloud infrastructure or belonging to the city or some other third party, and then we get all the results that we want regarding urban cities and mobility, urban traffic management, and for logistics. The first pilot we did a couple of years ago was in the city of Kalamaria. This is a city of near Thessaloniki, northern Greece, about 200,000 people. The method was using some commercial low-cost trackers that we put in some vehicles, very low-cost solution, and with only 50 vehicles, we managed to depict real-time traffic conditions in the city. We used, as I said, we developed a platform in the SUITS project. We call it mypolislive.net. Which was used to monitor the city traffic conditions, get all the location data from the trackers, and provide insightful information for policymakers. Another tool we are using in parallel for crowdsourcing is our navigator. As Boeing has been developing a navigator, satellite-assisted navigator like GPS, Galileo, and GLONASS, and so on. We call it UltiNavi, the ultimate navigator, and it's an application which offers free offline navigation with offline maps, free offline maps for the entire world. It provides incentives for the users to provide their location information, their routes, as they drive around, and both in real time as well as offline. So we get crowdsourced data from our users, provide them some offers in exchange as an incentive, plus the functionality of our navigator. You can get it for free from Google Play. There's a special version for car multimedia consoles. So the goal here is to have a navigator providing crowdsourced information and data from every vehicle to the city. And in this way, we get a lot of traffic data and very much accurate traffic, real-time traffic conditions for any urban environment. There's also another add-on inside the navigator. We call it Ultipol. This is for conducting surveys for transport purposes. So this is a useful tool as well to get feedback from our users, and the city and transport stakeholders can get advantage of this platform and tool as well. So we did the Calamaria pilot, which took like 4 months. We collected data from all the vehicles every 10-15 seconds. And we collected that in a platform that we have developed for this purpose. We call it mypolislive.net. It's a platform for urban mobility monitoring. And from this platform, we get several views, several visualizations of urban mobility, both in real time as well as for historical mobility. Here you can see, for example, in the upper left side, you can see we can be monitoring individual vehicles or vehicle groups. Here you can see visualizing the entire routes of a certain vehicle. We can also monitor, generate and monitor the entire city's road network for every city in the world. And this is done automatically, and this functionality is offered, is embedded in our platform. Many other interesting views. I'd like to show here that in the Calamaria pilot, with only 50 vehicles, we managed, with our platform, we managed to get real-time traffic monitoring at this granularity, which is very similar to an accuracy, which is very similar to Google, as you can see. And this is very impressive. In this case, we depicted the traffic bottlenecks the same way as Google they do, with just 50 vehicles for a city of 200,000 inhabitants. Here you can see that we also, through the platform, we can visualize historical data on a weekly basis for every day of the week, every hour of the week, and see traffic conditions on the map. Some other statistics and graphs for every road segment in the city map. You can have visualizations of speed distributions per segment, per road segment, speed graphs for individual vehicles, historical traffic load maps, like this one, for example, per day of the week and hour of the day. You can see the congestion based on historical data for this specific road segment, for every segment, and other graphs as well. One very important feature of our platform is that it distinguishes the traffic load from different sources. For example, it can distinguish freight traffic from city vehicle traffic or from citizen mobility traffic. And this is very useful because then we can do direct correlations of freight traffic, for example, with the rest of citizen mobility traffic, and do impact evaluation and get the impact evaluation of temporary and permanent mobility measures related to freight. Also, we can visualize the most frequency delivery points and most popular routes taken by freight vehicles, and other very useful conclusions that assist policymakers to get certain decisions. Historical traffic data can be segregated as well. For example, here you can see historical traffic data differentiated between among logistics, citizens, taxis and buses, and so on. Here's another example in the city of Thessaloniki of crowdsourcing. Thessaloniki is a city, second largest city in Greece, 1.5 million people. We use the same platform, similar platform based on the same platform basically, but this time we crowdsourced from an average 400 taxis. We got a very accurate picture of the city's real-time traffic conditions, as you can see here, with a very high granularity and accuracy in predicting and showing the bottlenecks of traffic at any time in real time. We conducted this during the lockdown of the first COVID period. So you can see here some graphs of the number of contributing taxis during the strict lockdown right here. Sorry about the Greek letters, and the less strict lockdown later on. So even during the COVID restrictions, we managed to get really quite good results from this type of data collection. Now, since we're talking about open data, I'm just going to show you here that in the SUITS project, we have developed an open data repository, and we have some guidelines on how to deal with GDPR requirements regarding anonymization and pseudonymization of traffic, of the collected traffic data. It's not straightforward. It takes some processing to do. It's not enough to just change the vehicle ID with some randomized sequence of or number. You need to do other things as well. So it's not so straightforward. Our data repository, we call it SUITS ODR. You can find it here in this URL. We have a visitor access point where you can just get and download data. This is what you see basically. You can search for the data you're interested in. So far, we don't have many data sets. We invite everybody to come and contribute your urban mobility data sets. This is how you contribute. You have to ask us for access credentials, and then we'll provide them gladly. And then you can. It's in a straightforward process. Just make sure that the data sets that you are uploading are anonymized or pseudonymized. In other words, GDPR compliant. And finally, just wanted to mention that our open data repository is registered in the Pan-European Registry of Research Data Repositories, retridata.org, so you can reach it from there as well. Thank you very much for bearing with me. And if you have any information, if you need any information on that, please send me an email or ask any questions at the end of this session. Thank you.
Our next presentation is where we go to Middle East and we see how open data frameworks or open data can empower ITS frameworks as the next step. And to deliver this presentation, we have Conrad Richardson. Most of you in the SMMR project might already know him. Conrad is the international technical advisor to the SMMR project and has long experience in smart mobility and ITS from his previous positions. I would not say more because Conrad has recorded a short introduction in his presentation. So Conrad, it's yours.
Thank you, Sunny. And thanks to everyone else for the great presentations. I saw a lot of presentations on very mature systems, and my presentation is slightly different. I will take it a step back, and I want to emphasize the importance of creating open foundations before you deploy any technology, which requires a lot of foresight, which is not often available in many of the ASEAN emerging cities. So I hope this talk is of interest, and without further ado, I will kick it off. Good day to all webinar participants. Thank you for joining us. It is with great pleasure that I will speak to you about ITS and open data best practices in the Middle East. My presentation will not so much focus on open data for public use, but rather on the need for open data architectures and frameworks within public entities to ensure data sharing capabilities, integration, and interoperability. If you're unfamiliar with any of the previously mentioned terms or concepts, do not worry, I will explain each in detail in my presentation. My name is Conrad Richardson. I work as the International Technical Advisor on the Summer Project and am based in Phnom Penh, Cambodia. Prior to joining the Summer team, I was most recently working as an intelligent transport systems engineer in the Middle East and North Africa for a company called Surface Mobility Consultants. And today I will be presenting at a high level an ITS project I worked on for the Dubai Road and Transport Authority, commonly known as the RTA. And so today I will cover the following items. First, I will give you a 1-minute introduction to ITS, what it is, why it's important, and how it relates to open data. Then I will briefly discuss ITS in the ASEAN context, covering what problems ITS can solve, but also some of the problems that can be encountered when deploying ITS solutions. Lastly, I will discuss how to govern and deploy ITS solutions most effectively through the implementation of best practice ITS frameworks and architectures. And we will cover this in a lot more detail in session 4 in 2 weeks' time. So without further ado, I would like to first ask you, the audience, what is ITS? I'm sure many of you know, but for those of you who don't know, let me break it down for you. Intelligent transport systems refer to technological systems and services for optimizing the movement of people and goods. And ITS is really everywhere, influencing our daily lives, often without us noticing. And before going any further, I would like to quickly touch on why we use ITS. As you're all aware, the movement of people and goods is increasingly complex, often far more complex than individuals can measure and manage without assistance of technology. And so ITS offers us automated monitoring and control systems that help us find comfort in ever-increasing complexity. And so there are many thousands of ITS systems and subsystems that make up a wide variety of services, and these are generally categorized by service domain. So for example, there exists ITS solutions related to traveler information, such as real-time passenger information systems. There's ITS solutions related to public transport. This might be the telematics units in buses that give us the bus geolocation. There are also ITS solutions that are related to transport-related payments. So maybe a road toll you might drive through to enter or leave a city. And with all these ITS systems and services, there are thousands of ITS vendors, all competing for market share. And some ITS vendors benefit from creating ITS solutions that can ingest data from third parties, like other ITS companies, or data generated by public authorities, or also crowdsourced data. And so they create open ITS solutions. While some other ITS vendors do not. Instead, they would much prefer a city or a country can only use their proprietary technology, and this is especially the case with very large companies, a wide range of products, who intentionally create closed systems and in doing so monopolize the market, which is great for them, but is not great for wider society because it does not foster innovation, it does not build new efficiencies, and it does not allow for flexibility in how the solutions are used. And so to avoid this trap, it is extremely important countries and cities develop open ITS governance frameworks and policies very early on. And this is explored further in the second half of the presentation. So as many of you are aware, many cities in ASEAN are already deploying such ITS systems and services. However, it is often the case that these are being deployed with very weak governance frameworks, and this runs the risk of creating closed systems that are unable to share data, that can't be integrated with third-party systems, and that are not interoperable. And this runs the risk of creating systems and services that are very hard to scale and cannot easily be locally adapted or integrated with local solutions. That being the case, it is extremely important that cities develop open ITS frameworks to manage and monitor and audit any ITS being deployed on the city streets. So now that you have an idea of what ITS is and why it's important, but also the benefits of open systems versus closed systems, we can talk about how to enable open ITS and how to avoid vendor lock-in through the development of ITS frameworks and architectures. An ITS framework is an essential structure for effectively governing and maximizing the potential of ITS. Back in 2018 and 19, while working for surface mobility consultants in the UAE, we were tasked with developing a multimodal ITS framework for the Dubai Road and Transport Authority. To do so, we sought international best practice from Europe and from the US Department of Transport to create a framework that would ensure data sharing capabilities, system integration, and interoperability across all ITS systems and subsystems. Together with this framework, we developed supporting policies and architectures with the fundamental goal of avoiding future potential vendor lock-in or duplication of efforts because ITS systems are unable to communicate with one another, and instead to enable ITS that can cross-communicate to ensure efficiency, flexibility, and third-party innovation. And we did so by abiding to the open group architecture framework known as TOGAF. As previously mentioned, as part of the project, we developed an ITS architecture, which is essentially a set of high-level views that enable plans to be made for integrating ITS applications and services. It normally covers technical aspects, plus the related organizational, legal, and business issues. ITS architectures can be created at a national, regional, or city level, and they help ensure that the resulting ITS deployment can be planned in a logical manner, integrate successfully with other systems, meet the desired performance level, are easy to manage and maintain, and also extend. When developing the ITS architecture, it is important to ensure standardization of ITS names, definitions, and technology architectures. It is possible and also advisable to use pre-existing standards, such as those used and developed in Europe and or in the US by the Department of Transport. Europe, for example, has developed FRAME, which is the framework architecture made for Europe, a framework created to provide a minimum framework necessary for the deployment of integrated and interoperable ITS. In the US, the Department of Transport has developed ARC-IT, which documents and codifies all kinds of ITS. When developing the RTA multimodal ITS architecture, we decided to develop a localized set of standards which merged various elements of the European FRAME and US ARC-IT standards to create a unique and tailored set of standards for Dubai. So to conclude, I would like to share with you the high-level ITS framework development methodology that we used in Dubai so that you can create an ITS framework of your own, one that allows for data sharing, integration, and interoperability. There are 4 key components to developing a high-quality ITS. The first is to assess the existing ITS, and this could be done by conducting a desktop review of existing documents, by meeting clients and running stakeholder interviews, by reviewing international and ASEAN best practice, and by reviewing all existing policies. The next step involves developing the ITS and architecture, and can also involve developing a catalog of desired ITS, and then developing a target architecture where the future ITS is envisioned, for example, up to 2030. The next step is to develop an ITS roadmap and maturity model on how you would like to reach envisioned target architecture. And lastly, this is related to developing the right governance structures and KPIs and auditing procedures to ensure the smooth deployment and also adherence to the ITS framework. And the final step involves communication and capacity building to ensure that within the public entity knows how to use and adopt the framework. So this concludes my presentation. I would like to say a big thank you for joining the webinar and sitting through my presentation. If you, your city, country, or the metropolitan region you work in are interested in creating an open ITS framework of your own, do not hesitate to reach out. It would be our pleasure to help guide you and point you in the right direction. My contact information is below. I very much look forward to hearing from you. The summer team would like to thank you for watching the Open Data webinar session. We had 4 sessions in total, introducing open data, discussing open data best practice around the world, and specifically in ASEAN, and also a session on how to make open data work. Throughout the month of November, we brought together a wide range of industry experts. Please see the other webinar sessions online. Thank you very much.